Today we're going to look at solving some triangles, in other words, finding angles and sides that are missing. And the key is none of these triangles are going to be right triangles. So in this situation, I'm going to look to find this value x here when I have these two angles and this given side. Now certainly I could find this missing angle by subtracting from 180, but finding this side is not quite as easy. We're just going to outline it, and then I'm going to talk about something called the law of sines that'll help us do this in one step. But if I really wanted to get this done, I'd have to probably drop an altitude. I could use a right triangle trigonometry ratio, because now I have this right triangle here on the left side, and I have a hypotenuse, and I'm looking for an opposite, so I could find sine. Once I have that, I can take and use actually sine again, because I have an opposite and a missing hypotenuse to find this angle right here. So I could probably get this done in 3 steps. Not a big deal. But let's talk about a proof that would allow me to get everything done in one shot. Let's say this is A, B, and C. And always when we write triangles, we take our sides and put them in small case letters directly across from the uppercase letter angle. So little b and little c. And let's say we're given the following. We're given the angle A, just like in the last problem, the side C, and the angle C. And we're looking to find this side A. Well, once again, we're going to kind of deal with this the same way we did in the mock-up problem prior. We're going to draw an altitude, call this h. And now I could say the sine of A is equal to h over c, but I also know the sine of C is equal to h over A. Now, doing a little bit of algebra, I can multiply c to both sides, and I get c sine A is equal to h. And multiplying a to both sides, I have a sine C is equal to h as well. Therefore, since I know both are equal to h, I can say c sine A equals a sine C. And again, with a little division property, I can say the sine of A over the side A is equal to the sine of C over C. And what that does is it now gives me one equation in which I have 1, 2, 3 of the terms, and I'm only missing 1. So I can solve for A. This is called the law of sines. And the law of sines states the following. It says the ratio of a side to its opposite angle and the sine of it is equal to the ratio of the other sides and the sine of their opposite angles. Likewise, I could write it as the reciprocal relationship. The sine of an angle over its opposite side is equal to the other sines of their angles and over their opposite sides. And we want to do this when you have an angle side given or a side angle. So let's go back and do that problem that we started with. We have an angle side given, so we can use our law of sines, and I want to find x, so I'm going to put my side or my unknown on top. I say x over the sine of 55 is equal to 8 over the sine of 26. And now I can multiply by a sine of 55 to both sides, so 8 sine of 55 over sine of 26 will equal my x value, and now it's turned into a calculator problem. And we end up with an x value of 14.95 if I round to the 100th. And you want to make sure your calculator is in degree mode when you do this. So now it asks us to solve a triangle ABC given the following values. Again, it looks like we're going to have an angle, and a side. Now, once again, when we create these triangles, it doesn't matter where you put the letters for A, B, and C, but it does matter once you set those angles where you notate their sides. So opposite this angle C has to be the side of 16. And what they're asking us to do in this triangle is solve it, which means find all missing sides and all missing angles. So let's tackle the easiest part first. Let's find the missing angle. We know there's 180 degrees in a triangle, so therefore C equals 180 minus what's already been used, 120, or 60 degrees. So I'll just fill that in. And now we're left to find both B and A, those sides, so we're going to have to write two separate ratios. I'll find A first, let's say. So A over the sine of 40 is equal to 16 over the sine of 60. So just like the last problem, multiply sine of 40 to both sides. I have 16 sine 40 over the sine of 60 is going to equal A. And we end up with 11.88 for A. Moving on to side B, we take B over the sine of 80 is equal to, and I'm going to use what was given to me in the problem, anything that doesn't have rounded answers, because once I start using rounded answers to calculate a new answer and then round that, then I have multiple rounds, which isn't as accurate. So I'll take 16 again over the sine of 60, multiply by that sine of 80 again. I have 16 sine of 80 over the sine of 60 is equal to B, which gives me 18.19. And now I've solved the triangle because I've found all the missing sides and all the missing angles. Next thing we're going to do is find the area of a triangle. Now, I'm not a big fan of special equations for this, although we can use one, and I'll show you how to do it in just a sec. I know in this triangle I have 25 for my side, or for my angle, I'm sorry. I have side B of 21.1 and side C of 16.5. Now, me personally, I know that I've got 1/2 base times height gives me an area of the triangle. So really all I need in this problem is a height of the triangle. And I can get the height, h, by using a sine ratio and just say I know the sine of 25 equals h over the hypotenuse. Right? And then I have the base, which is 21, and now the height, which I'll solve for. I know h, in this case, will equal 6.76, and then the area equals 1/2 21.1 times 6.76, which is going to give me 71.32 square units. Now, again, I said, well, there's a formula we could use to get this done, and the formula is actually pretty easy. Let's say we've got a triangle given to you, and we're given a side angle side. So let's say, once again, A, B, C, and this is little c, this is little b, and this is A. Again, we'd have to drop an altitude like so, and once we drop that altitude, we could say this is our height, and I'm given A, C, and B, and I want to basically calculate 1/2 base times height, which is what I did in the last problem. I know that the sine of A is equal to H over C, which was given to me. So C sine A equals H, and then one area equals 1/2 the base, which is B in this case, times the height, which is equivalent to C sine A. So really, the area equals, let's write area because I have this other A right here, equals 1/2 BC sine A, or in other words, 1/2 two sides multiplied together times the sine of the angle. And this is only if side angle side given. So we can use this formula if we want, but again, I think it's just as easy to go 1/2 base times height. So now we've got a word problem, and the hard things about the word problems is you're going to have to draw the picture on your own. So you've got two cables with separate lengths that extend from the top of a television antenna, which is level to the ground, and on opposite sides of the antenna. So what the heck does that mean? It means that I've got some ground, I've got some antenna going up, and then I've got these two wires coming off the top of the antenna. One here and one here. And notice they're not the same length. So I know the longer one's 300, shorter one's 270. Longer cable makes an angle of 48 degrees with the ground. So here's the longer angle it makes with the ground is 48. And we want to find the acute angle of the shorter cable on the ground. So we basically want to find theta right here. Alright, and this is really set up nicely for a law of sines problem because I have, if you'll notice, I have two sides at an angle given. Alright, and here's the missing angle. So I could take and find the sine of theta over the opposite side, 300, is equal to the sine of 48 over 270. Again, I'm going to isolate what I need. So I have 300 sine 48 over 270. Sine theta will equal, this is a calculator problem, 826. That's rounded. Now what I'd want you to do is in your calculator leave whatever number you get by doing this multiplication and division. And now the unique thing of this problem is we aren't done yet because we're trying to find theta. So as we did in our right triangle problems, we have to find theta by taking the inverse sine of both sides of the equation. So when I do that, I pop that into my calculator and get about 55.66 degrees. Up to this point, all we've dealt with our law of sines problems are given two angles and a side. But we know that law of sines can be used for a side-side angle as well. And given that side-side angle case, there can actually be multiple types of solutions. 0 solutions, 1 solution, or actually 2 solutions for a given triangle. And we're going to take and go through each of those with this side-side angle given. So here we have a triangle where angle A is 145 degrees. We have side B of 10 and side A of 2. So here is angle A, here is side A, here's, let's call this B right here, 10 here, and C right here, and little c here, and we want to solve that triangle. Now right off the bat, I'm looking at this and going, hey, there's something up here. And if I look at this, I say, well, 145 has got to be my biggest angle. Now, from geometry, we know that the biggest side has to be opposite the biggest angle. So, once again, in this case, we have a side, and an angle given, which is the premise of the day, but I don't have the biggest side opposite the biggest angle. This is an invalid situation that they've given us, so we say there's no solution. Let's say you don't recognize this right off the bat. You can still set up law of sines and say that the sine of 145 over 2 equals the sine of b over 10. Therefore, 10 sine 145 over 2 equals the sine of b. Sine of b would be equal to 2.86. And then when I take the inverse to find b, I get a no solution case. So it would come out in your calculations even though you don't recognize it. So here's a situation where I have a side followed by a side followed by an angle, and there were no solutions. So we took care of that one. Now, in general, how do you know whether there's going to be 0, 1, or 2 solutions? Well, here's some rules for you. Given that you've got a side-side angle, if the side opposite the given angle is greater than the other side, there's only going to be one solution. If the side opposite the given angle is less than the other given side, there's either going to be 0 or 2 solutions. Not 1, but 0 or 2. So in this last problem we had, let's take a peek. We were given a side, and an angle, and the side opposite the given angle was less than the other side given, because 2 is less than 10. And we had 0 solutions. So that fits this last premise right here. The side opposite the given angle is less than the other given side. There's either 0 or 2 solutions. So let's go through these other situations. So in this case, we're looking to solve this triangle where A is 126, B is 12, and C is 2. So here again is a side, and an angle. And the side opposite the given angle is actually greater than the other side. So by our rules, side opposite the given angle is greater than the other side. There's only going to be one solution. So I know I'm only going to have one triangle in this case. So let's start using law of sines. We can find angle C first. So the sine of C over 7 is equal to the sine of 126 over 12. Sine C equals 7 sine 126 over 12. And I end up with the sine of C equaling 0.472. So C is equal to the inverse sine, 0.472. Again, we'd leave that in our calculator without rounding. Will be C is equal to 28.16 degrees. So let's just write in 28.16. Now I know I can use a subtraction from 180 to get angle A. A equals 180 minus 126 minus 28.16, and I get 25.84. And then finally I need to find the side A, so I take A over the sine of 25.84 is equal to, I'm going to use the given information, 12 over the sine of 126. Therefore A is equal to 12 sine of 25.84 over the sine of 126, and A will be equivalent to 7.09. And we've solved the triangle. So again, we've dealt with the following two situations, side opposite, given angle greater than the other side, where we had one solution, side opposite, given angle less than the other side, zero solutions. So now we're going to deal with the two solution case. So let's go through and do that. So in this case, I have angle B is 35, side B is 50, side A is 65. Two sides and an angle given, side opposite the given angle is less than the other side. And we're going to state that there's two possible solutions. Well, let's find the first one. We'd have to use a law of sines to calculate A. So I know that sine of A over 65 is equal to the sine of 35 over 50. So A, just like in our previous problems, is equal to the inverse sine of whatever 65 sine 35 over 50 equals. And that gives us a value of 48.21 degrees. I subtract from 180 to get C. So C equals 180 minus 35 minus 48.21, which ends up being 96.79 degrees. And then I could find side C by doing another law of sines. So C over the sine of 96.79 equals 50 over the sine of 35. C equals 50 sine 96.79 over the sine of 35, or 86.56. So let's go ahead and write some of these in. I know in this case that I have this side A, or angle A, of 48.21, and this is 96.79 rough. So now, but this is a situation where we said that we're going to have 0 or 2 solutions. Well, I've already found one solution, so how do we find the other solution? Well, the situation is this. No matter what happens, I have to keep my initial conditions. I have to keep that, basically, I have a side of 65, a side of 50 next to each other, and this angle connected to the 65 of 35 degrees. Well, if that's the case, then I can use now this compass to find my other side. Now, you don't need a compass, but what you do need to know is that a compass draws circles, and on a circle, any line that I draw from the center point is equally distant from that point, because that's the definition of a circle. So I take and I bring this point up here and say, hey, right now the distance from C to A is 50. Now if I swing this at all, what happens is I create an arc, and on that arc I am equidistant from that point C. So let's go ahead and actually draw this now. Here's that arc, and notice that arc comes back and hits the triangle again. So given that, what I know is that I can draw a line from that point to that new intersection and create another triangle such that I have a side of 65, a side of 50, because this dotted line is still 50 away because that's on the same arc of the circle, and an angle of 35. My new triangle looks like this green guy right here, which certainly looks nothing like the initial black triangle. If but I still have the same initial conditions. Now the key is, well, how do I know which side I move? Well, there's a way to do that as well. Basically, what you want to do is you want to use the angle between the given sides is your pivot. So that's the point, or that angle is the vertex of the angle that you swing. Then you want to swing opposite side. So here's the opposite side into the given angle. So here's that opposite side, and we swung it into the given angle, and you'll create this new triangle. Now in this new triangle, here's something we know. Again, here's my new triangle to the left, but in the triangle to the right, this triangle is an isosceles triangle because I have two sides of 50. We know from geometry that base angles are equal in an isosceles triangle, so this angle over here is also 48.21. I know that this is a straight line, so 180 minus 48.21 is going to give us that supplementary angle, which means that this guy right here is 131.79. And if I know that's 131.79, I now know this angle up here because I just have to subtract from 180, which gives me this angle C being 13.21. Finally, I can find my missing side C by using a law of sines and just say the sine, or C over the sine of 13.21 is equal to 50 over the sine of 35. And we end up with C equaling 19.92. So we have one solution of the triangle in black here, the other solution in the green and red down here, and those are our two triangles. Again, follow this rule. Take the angle between the two given sides as your pivot, swing the side into the given angle, thus creating an isosceles triangle, and then you can get all the pieces of this little triangle. Let's do it again just for practice so you can see it. We take and find C. So what I'm going to do is I'm going to create my triangle. I got a 65-degree angle for A. 15 is the side opposite. Call B, I guess right here, C up here, and side B is 16, so I have the side opposite the given angle is less than the other side. There should be two solutions. All I'm really concerned about is finding angle C, so I'll go ahead and find angle B first since that's the only thing I can find. We'll take the sine of B over 16 is equal to the sine of 65 over 15. B once again is equal to the inverse sine of 16 sine 65 over 15, which is 75.17. Subtract that from 180 to get C. C equals 180 minus 65 minus 75.17. We have a C value of 39.83. So that's one possible situation. And we knew B was 75.17. So now I'm going to take the angle between the two given sides, use that as my pivot, and swing the side opposite into the given angle. Something like this. Doesn't have to be totally accurate, but I'm going to create a new triangle. And in that new triangle, this dotted line is also 15, so that base angle is equally 75.17. Therefore, I have a new triangle, like so, where I have 65, 15, 16, and this right here is 75.17. So now if I subtract from 180, I end up with 104.83 as this angle down here. This is my new B, if you will. And then I can find my new C by subtracting from 180 again. And I get a C value of 10.17. So here's one value of C, here's the other value of C, and there's a couple examples of how to swing that. Again, side angle is the theme of the day, and you've got to pay attention to how many solutions you're going to have as a result.